Hey everybody, the Network Berg here. In today's video we will be discussing VRRP on FortiGate devices as well as EOIP on a MikroTik. These are lectures we've gone through before. I think the VRRP we did on a Cisco device, but the principle is the same. So our objectives actually are to have a LAN subnet and span this across from one data center to another data center where our servers could potentially share the same IP addresses, and in the event that the one data center goes down, you'd be able to seamlessly fail over to the other data center. There's a few benefits to this, and there's really cool things that you can do to make this work for yourself. So you see I've got a topology in front of me. It's fairly basic. Well, it might look intimidating to some people as well, but don't overthink a diagram. If you see something, just look at it at a objective manner. We have some switches, you see. Here's switch 1, here's switch 2. Think of this as data center 1 switch, data center 2 switch. We have server 1 and we have server 2. So think of that as the server that plugs into that switch on data center 1 on switch 1, and server 2 goes into switch 2 of data center 2. Then we've got some uplinks to a router and a firewall for data center 2 here. Same thing at data center 1, firewall uplink and a router uplink. Generally you might see something more in line with 2 uplink cables to the switch and then 2 uplink cables from the switch to the firewall. I just did it this way for some simplicity because I didn't want to span some additional VLANs on the switches. That's just me being lazy, but it doesn't change anything on how the setup works or how the solution will turn out working. And then we've got some uplinks to the internet where we've got internet access. So I've already done pre-configuration for the firewalls and the routers just to give them IP addresses and make sure that they've got some network connectivity. So here's router 1. From here I've got internet access, and from here I've got WAN IP addresses assigned to my routers and my firewalls in the 169.255.255 subnet. So let's quickly just see if I can get to those devices. So this is from router 1. Dot 1 is router 1's IP. Dot 2 is firewall 1's IP. Dot 5 is router 2's IP. And then dot 6 is firewall 2's IP. So we know there's network communication. These devices are able to communicate with each other. They're able to see each other, but they're still 2 separate DCs. So you can make separate changes on either. It's not like you're putting these firewalls in a cluster. These are going to be their own firewalls. We're just going to set up VRRP in the event that either one firewall dies, that it can fail over to the other firewall, or if you maybe want to move some certain servers from one DC to another DC, maybe it's due to maintenance, maybe it's some other reason that you need to do that. So let's quickly jump into the configuration, because we've discussed a lot of the theory now of what we want to happen. So let's get onto the routers, because we are going to have to configure our EOIP tunnel firstly, because these servers and the firewall does have a VLAN configured for it, VLAN 163, which I've said is for a DMZ. And that's what we're going to try and span. So let's just jump on our routers. That's router 1. And I'm just going to connect to router 2 at the same time. Dot 5. Alrighty. That looks okay. So let's just look at the IP addresses again. Looks fine. I see my internet's not up on router 2, but that's not too concerning. We don't need to worry too much about that, because our objective is literally just EOIP and VRRP to see if we're able to send the VLANs across over the EOIP tunnel, and also to do that VRRP failover. So if you remember from my other video, we're going to set up the EOIP tunnel by going to the interfaces. We can go to EOIP tunnel here, interfaces, EOIP tunnel, and we'll just create a new tunnel on both ends. So we can leave the name as EOIP tunnel 1, or we could make it EOIP tunnel -DMZ -client. The remote address for the EOIP tunnel, that's always going to be the router, the other MikroTik that you're forming this EOIP tunnel with. 169.255.255.5, and your tunnel IDs needs to match. I'm just going to make it 163, keep it relevant to the VLAN, apply that, and let's jump here, EOIP tunnel, click on plus, EOIP tunnel, DMZ client, and our remote address is going to be 169.255.255.1, which is router 1's IP address that router 2 can get to. Tunnel ID 163, apply that. So the EOIP tunnel should already be connected. If I look at the status, it is running. So that looks good. So our next objective is to make sure that we have, let's get to our interfaces. We want to just add actually the VLANs. I want to add VLAN 163 as well. We're not going to give it an IP. We're just going to be able to span the VLAN across. So let's call this DMZ client VLAN 163. The VLAN ID is 163. And we can assign that to the port that's running towards the switch. So in our topology, that is Ethernet 2. So Ethernet 2. Apply that. I'm going to do the same on router 1, that was on router 2. DMZ client VLAN 163. VLAN 163. So that should be Ether 2, switch uplink, apply. So now I've got a VLAN, I've got an EOIP tunnel. So I want to be able to mush them together in a bridge so that they can start to communicate. So let's create a bridge. Click on the plus, call the bridge EOIP DMZ bridge. It doesn't matter too much, this is just your naming. So whatever you feel comfortable with, you can call it that. And then the ports, we're going to assign our ports here. So we're going to assign the EOIP tunnel to the bridge, and we are going to assign the VLAN to the bridge. Just make sure, if you have multiple bridges, just make sure you select the right bridge. Same thing this side. Let's call it EOIP DMZ bridge. And it's easy to create a bridge. Let's add the ports to the bridge. So we are adding the EOIP tunnel. And it doesn't matter what order you add the ports in. That's irrelevant, just as long as you do bring them in. And let's add the VLAN. Apply that. Okay. So now, in theory, we should have spanned the VLAN across both networks. So if we look at our topology, the VLAN 163, it's on the switch, it's on this firewall. We've got it on the router, but we've created an EOIP bridge on both ends, where VLAN 163 is also spanned to this switch and this firewall. It's untagged towards the servers, and the servers both share the same IP address. But let's just quickly see if this is up. So I'm going to jump onto server 1. Let's just quickly go onto the terminal. It's just so we can do some pings. I think I've put them in the 10.4.0 range. .1 is going to be our VRRP IP. I haven't configured this yet. But .2 is firewall 1's IP. So let's see if we can get there. We can get there. That's great. Let's see if we can get to .3. We might have some issues getting to .3, but it does reply. I think it's just I'm worried because this server has the same IP, but it's not an issue. So we do have an EOIP tunnel where the firewalls and servers and switch is on the same broadcast domain on VLAN 163 now, which is amazing because This allows us now, since we're able to do that layer 2 communication with the VLANs, we can do VRRP between our firewalls as well. So let's quickly do that. Let's jump onto firewall 1. Admin blank. This is a virtual firewall. I'm just gonna open up firewall 2 as well. This is FortiGate devices. It is pretty straightforward to do the configuration on FortiGate. I tend to do this type of configuration through the command line, but you can do it through the GUI as well. I just feel like it's more work through the GUI for some reason. So to do the VRRP, we need to get into the system interfaces. So we're going to do config system interfaces just to get into that configuration mode. It's similar to the Cisco iOS type of command structure. You go into that subsection and you start working from there. Config system interfaces. So I know that it is going to be on port 2, but let's look at our topology. So there's the firewall. Port 2 of the firewall goes into the switch, and that is what the servers use for that broadcast domain of VLAN 163. We're actually going to do the VRRP on that VLAN. So let's say edit. I'm just going to question mark it because I know I've got the interface already. It's called DMZ_client, all caps. All right, and it is a VLAN. So from here, we need to edit. Let's just check config VRRP. We're going to edit. When you edit here, this is like the VRRP group ID that you're doing. So let's say this is going to be 163 as well. Now what we're going to do is set. We're going to set two things. We're going to set a VRRP IP, because that is the VRIP. What is our VRRP IP going to be? So in my case, it's going to be 10.4.0.1. And we need to set our priorities as well. Set priority. And remember, with VRRP, the higher priority is the one that is being picked. So let's just set firewall 1 to 255. That is the highest priority. And we can just end this. So what we can do now as well is just get out of here, execute ping 10.4.0.1. So the IP is live now. VRRP is doing its thing on firewall 1, but it's not yet configured on firewall 2. So we're going to do a similar thing here. Edit DMZ client. We're going to configure the VRRP. We're going to edit 163. We're going to give it a VRIP, which is going to be 10.4.0.1. Okay, I feel like I've done something wrong. Okay, it's set VRIP 10.4.0.1. Set the priority. And this one is going to be set to 50, but you could make it 100, just as long as it's less than what's on firewall 1. Next. End. End. Let's see if we can actually reach that IP from here. Okay, this is because of the VRRP IP, the VRRP mode and such that was still figuring out where what was. So now in theory, we've got VRRP configured on both firewalls, on both of their LAN ports, going to the server infrastructure. So let's say, let's jump onto server 1 again. Let's see if we can ping 10.4.0.1. We can. And that is firewall 1's VRRP IP. Remember, both firewalls have the same VRRP IP. So I'm just going to run this as a continuous ping. I'm quickly going to jump onto firewall 1. I'll do this from the GUI just so that you can have a graphical view of what's happening. I'm just quickly dragging IE across because I'm just going to use that. 169.255.255.2. Admin blank. I'm leaving the window there so that you can see the ping happening in the background as well. Okay, so we're on the firewall. So what I want to happen now is I want to take this DMZ client interface. I'm going to right click it. I'm just going to disable it. Look at the ping on the left hand side. Just waiting for that VRRP IP to kick in. Alright, it took a bit longer than usual to kick in, but 10.4.0.1 did come live. You can see it on the left hand side. It is responding still. The DMZ client is disabled. So that port is affected. The port is up, but the VLAN that we're using that for is down. So server 1 is technically going to switch 1, gets to router 1 because that broadcast domain is there. The VLAN is still spanned there. And then over the EOIP, it's carrying the VLAN to router 2, which brings it to the switch 2. And then finally it gets to the firewall. I actually think I'm having some issues because both servers are live at the moment with the same IP, and you know you don't want duplicate IPs on your network. It can cause all kinds of havoc. So what I'm quickly going to do is I'm going to shut down server 1. Stop that. I'm going to bring up the VLAN again on router or firewall 1. I'm going to jump on server 2 now. Let's just see the server 2 have comms. Ping 10.4.0.1. It does. And that is still going over the EOIP tunnel, so that's going to firewall 1 now. So what we can do is shut firewall 1's interface again. So you'll see there is a drop in connectivity there. And the moment, there we go, it continues again. So that's what I expect to happen. I think it's earlier just because we had the multiple IPs. The reason I did want to have multiple IPs is just to showcase to you, if you have multiple servers with the same IP address, how easy it is to fail them over. Because what I can do now is we can put this DMZ client back on. So it will use firewall 1 again as the primary device. And I'm going to start server 1 again. I'm going to, and remember they've got the same IP, ifconfig 10.4.0.50. So if I disable this one, stop it, get onto server 1, I just want to see that it keep the IP address. Alright, it did not, but I'm just going to assign the IP. I find this happens a few times on these Firefox VMs. It's got a very small version of Linux running on it. 10.4.0.50. And .1 is the gateway, which is the VRRP. Let's quickly test this. So now .50 is on this DC at DC1. It's no longer at DC2. And we should already know that we've got comms with the VRRP 10.4.0.1. Alright, that's perfect. So it is all working. We do have VRRP running between our two firewalls. And this is over an EOIP tunnel. You don't need to use EOIP. It's just if maybe you're using MikroTik router or MikroTik routers, it might be easier for you to set that up. But if you're running a big network or you've got MPLS running, you can span this over VPLS as well. It's kind of the same concept, does the same thing, but that's it. I hope this video taught you maybe something new. Maybe you can implement this yourself for your own disaster recovery or find another use in your network for failover on this. I'd like to thank you for watching. I also recommend again to subscribe to the channel. Thanks for watching.